Your FastMCP server runs great in development, but now you need to manually wire it into Cursor's configuration without breaking isolation or missing dependencies. We'll see exactly how to structure the mcp.json file so Cursor can launch your server with all required packages, the right Python version, and even environment variables, using just a single uv run command. No more trial and error configuration.
MCP servers. Dice roller. Command uv. args. Run. With FastMCP. With pandas. With requests. FastMCP. Run. path/to/your/server. Pi.
This demonstrates the configuration as code pattern for dependency management and runtime environments. The JSON structure defines a complete execution context, including the command runner, package dependencies, and entry point, all in a declarative format. What makes this distinctive is how it encapsulates both the runtime requirements and the execution command in a single, portable configuration. The pattern works by externalizing environment setup from application logic, using the command runner, here UV, as an isolated environment manager. FastMCP leverages this to create reproducible execution contexts where dependencies are resolved at runtime, not development time, ensuring the server runs with exactly what it needs regardless of the host system's global state. This separation of concerns allows tools like Cursor to spin up servers in clean, controlled environments without manual setup. This approach matters because it solves the works on my machine problem for AI tool integrations. By codifying the entire execution environment, you eliminate implicit dependencies and version conflicts, making servers truly portable across development, testing, and production. The trade-off is a slight startup overhead for environment creation, but the reliability gain for distributed systems or shared tooling, like AI assistance, makes it worthwhile for anything beyond trivial scripts. Let's break it down line by line. This opens a JSON configuration object. The outer braces define the root structure for FastMCP server configurations, where each key represents a distinct server instance.
MCP servers.
Defines the MCP server configuration block. This is the root key where all server instances are declared, following FastMCP's standard configuration structure for multi-server deployments.
Dice roller.
This defines a named server configuration called dice roller within the MCP server registry. The key acts as both an identifier for this specific service and determines its accessible endpoint path, enabling FastMCP to route requests to the correct server implementation.
Command UV.
Specifies UV as the process runner, the standard tool for executing Python applications with optimized startup and resource management. This replaces Python M with a faster, more reliable alternative that handles dependency isolation through the with arguments.
Args.
The args array defines command line arguments passed to the UV process. This is the standard pattern for configuring executable parameters in JSON-based process definitions, where each array element becomes a separate CLI argument. The order matters. It determines how the command interpreter processes these flags and values.
Run.
This is the FastMCP execution command. It tells the server to start running the specified Python script as a FastMCP service, making all decorated tools available to connected clients. Without this, the server would only load configuration without activating the service.
with FastMCP.
This specifies FastMCP as a runtime dependency for the server process. The with flag tells the FastMCP launcher to ensure the package is available before execution, preventing missing dependency errors at startup.
With pandas.
This includes pandas as a runtime dependency for the FastMCP server. The server's data processing tools likely rely on pandas for tabular data operations, so this ensures the dependency is available when the server starts.
With requests.
This includes the requests library as a dependency. FastMCP needs it for HTTP-based tool calls, enabling external API interactions from your server.
FastMCP.
This specifies the FastMCP CLI entry point, the core command that actually launches your MCP server. Without this, the previous with flags would have no target to configure.
Run.
This is the FastMCP execution command that triggers your server code. It tells the runtime to start processing the server, PI file with all previously specified dependencies and configurations. Without this, the command would only validate the environment without actually running your service.
path/to/your/server, PI.
This specifies the entry point for your FastMCP server. The path must point to your server, PI file containing the @mcp tool decorated functions, as this is where FastMCP loads all available tools from. Without this, the server would start but expose no callable endpoints. Closes the argument list for the uv-run command. This square bracket terminates the array of CLI arguments passed to the uvicorn server, finalizing the command configuration before execution. This closing brace terminates the dice roller server configuration block. It maintains valid JSON structure by properly scoping the nested key value pairs for this specific MCP server definition. This closing curly brace terminates the dice roller server configuration block, completing the nested JSON structure. It maintains proper syntax hierarchy, ensuring the configuration remains valid and parsable by the FastMCP launcher. Without it, the entire MCP server's definition would fail to load. Closing brace terminates the JSON configuration block. This ensures valid JSON syntax and prevents parsing errors when the file is loaded. Without it, the configuration would be malformed and rejected by the parser. FastMCP dependency configuration. The uv-run pattern with flags creates isolated environments for each server, ensuring dependency purity while maintaining reproducibility across systems. The order of arguments matters. Python version and project settings must precede package specifications, or the configuration will fail silently. This approach eliminates works on my machine problems by making environments explicit and portable.
The server that depends on nothing becomes available everywhere.